Let's then look at the Spearman's rank correlation coefficient, which, as the word suggests, is used to determine if there is a significant correlation between two variables. Now, this is where it could get a little bit confusing for you, in terms of choosing. If you have a question that, if the question tells you which statistical test to use, great. If it doesn't tell you though, and you have to make that judgment, which you may, okay, if we have observed and expected, we know we're going to use the chi-squared test, and it's most likely going to be in the context of a genetics question. But if we have two, both in the t-test and in the Spearman's rank, we're going to have two separate data sets, right? In the t-test, it's going to be two populations. You're going to be comparing their means. In Spearman's rank, you're also going to have two different data sets, because you're comparing how one data set, whether one is affected by the other. You want to see if there's a correlation between them. Again, it will have to be the context of the question. We're going to see an example in a minute, right? In the Spearman's rank, you suspect that one data set, that one set of values affects the other, or that there's a correlation between them, that one increasing will cause the other one to increase. So for example, here we have a correlation between temperature and the number of ice cream sold by an ice cream van, right? Does one affect the other? This is what I want to find out with my Spearman's rank. If the coefficient is greater than the critical value, again, that we read off tables, then there's a significant correlation between the two variables. Correlation doesn't mean causation. You know that very well by now. But we can state whether a correlation is significant or not. The null hypothesis, sorry, there appear to be like the little things missing. The null hypothesis for the Spearman's rank test is that there's no significant correlation between the two variables. So basically, if we are going to have a little like a graph here between the two variables. So for instance, here I have what I call, if I were to draw a line of best fit here, I have a positive correlation. Here I have a negative correlation. And if my data were completely sort of randomly scattered like that, then I would say that I have no correlation. The Spearman's rank, the requirements to be able to use that test, it doesn't actually require the data to have a normal distribution, unlike the t-test. And the correlations are going to be linear and will be either positive or negative. Let's have a look at an example. So a teacher is investigating if there is a correlation between students' test results in biology and geography, right? The teacher compares the test scores of 10 students and performs a Spearman's rank correlation test, and the results are shown here. Complete the test and state your findings. 6 marker again. So that's why I'm saying the tests, they're a worthwhile investment because they're worth a lot of marks. And at least there's no ambiguity about what you need to do. The context are going to, of course, be the data provided. And the command word is complete and state. And the direction is that you're using the Spearman's rank test. So let's have a look at what the formula for Spearman's rank is and how you use it. You will be given the formula as well. You don't need to memorize it. So this here is my formula. So let's kind of like break down what the formula contains. D here stands for the rank difference. So difference between what? The difference between my two variables that I want to test for, whether they've got a correlation. So for example, here are my biology test scores, here are my geography test scores. What is the rank? What is this rank that I have to calculate? I basically have to rank these values according to size. So for example, what do I mean by that? Let's take the biology rank first. So I see this score here, 94. It's my highest value, right? If I look down those values, I can't see a larger value than 94. So that takes a rank of 1. That is my highest value here. What is my next highest value in this data set? Well, it looks like it's 82. So that is my rank number 2. What's the next highest is 79, rank 3, and so on. I will then do the same for the geography rank, and then I'm going to subtract. So for example, geography rank here is 8. 39 is the 8th biggest value. This is the 4th biggest value. And then I will subtract 1 from the other, right? So if I subtract 8 from 1, I get -7. And then I take this column and I square it. Okay, so this is the rank difference, D. And this column is for D squared. I then, of course, take the squared rank difference, which is in this case, sorry, the sum of, I don't know why this happened, the sum of the squared rank difference. So down here, I basically add up everything together, and I get, if I add all of these up, I get 217.5. 217.5. So this is this. Multiply it times 6 because that's my formula, which gives me 1305. And now for the denominator. N, of course, is the sample size, the number of individuals. In this case, the sample size, if I calculate this entire formula, it gives me 990. So therefore, my entire Spearman's rank value that I calculate is minus 0.32. Don't worry about the fact that it's a negative value. What does it indicate? That I may have a negative correlation. Okay, so it's fine to get a negative value. What do I then do? I have to, of course, compare the value that I get with the critical value from a table. Now, so we've got a value of minus 0.32. How do I calculate the degrees of freedom? So the number of pairs of measurements. So I had 10 separate measurements. That's my critical value. And I get 1 mark for each. And I compare the two. So for the 0.05 confidence interval, the critical value here is 0.648. 0.648 here. And since my value is smaller, then I cannot reject the null hypothesis. So I've got a significant sorry, insignificant. It's due to chance. Okay, that's it, guys, for today. Best of luck in your exam.